Hi, this is Dandy Taylor, one of the students for the CPSC 442 course, Python for Data Science, and this is the demo of my semester project. So in order to do the project, what we were asked to do is create some data analysis solutions, ask some questions of a given set of data, and then do the data analysis using pandas, and then to create an application, web app, whatever, that would display that information and make it interactive in some way. And so up here on the screen, I have the code that I wrote. In this particular case, there's actually just two files. The first file is the app itself. What I chose to do is use Dash and Flask. So Dash is a data visualization dashboarding tool or library that can be run inside of a Flask server. And I chose to do this so that I didn't have to worry about installing anything in IIS or in Apache. It runs the server for me and creates right there. You can run these out in some of the different hosting systems as well. I'm just going to host it on my local machine as we go through. So how this works is the first thing I do is I go in and I've created a class called the movie repository. We'll look at that in just a minute. I'm going to get that repository of movies. I'm going to create my Flask server here on line 11, and then the application, the Dash application, on line 12. And then I'm going to set up the layout of how I want this. This is pretty basic because I honestly was running out of time. And so it's just going to put each of the graphs in order. And so what you can see here is that it starts out with an HTML div, and then it defines the children for that div. And in this case, we have one big H1 that's going to say pandas for data science, and then we have all the series of graphs that we have from the movie repository. So we can get ratings by actor and by director, genre, revenue, and year, and then we can get revenue by actor, director, genre, rating, and year as well. And so that made it pretty straightforward to create the UI part of it, and that left most of the work to be done inside of the actual repository and using the pandas to do the data munging. And so that's the app itself, but like I said, most of the work is in the repository. And so here you have the repository class. It has a few internal members, a file name, which is going to direct us to where the file is, the movies, and then I split off certain parts of the movies data set for use in different ways. So we have a list of actors, genres, revenue, ratings, directors, and years. And we're going to initialize all those. So for the most part, this is pretty straightforward. When we in our init, we're going to go ahead and set the file name. We're going to read the CSV file in. The first thing we are going to do, though, however, is we're going to clean up the movies data set. And so if I come here and go to the definition, you're going to see it's actually right here, starting on line 27. The first thing we're going to do is we're going to rename a couple of the columns because the names of the columns have spaces and punctuation in it. We're just going to take that punctuation out and put an underscore for the space, make it a little bit easier to use for both revenue and runtime. The next thing we're going to do is there is one column called Metascore. It's actually used by IMDb. I'm not using it at all, and so I'm just going to get rid of it. I'm getting rid of it because there's a lot of null values in it. And so just deleting it off of the data set. The other thing I'm going to do is go through for all of the rows that have nulls that are left over and get rid of those as well. Most of those nulls are in the revenue column once I got rid of Metascore, and so I wanted to make sure that I had data that had revenue, because if there's no revenue, then it didn't wouldn't really work for the kind of analysis that I'm doing. So it's going to clean that and then come back here and set the values, set it back to the movies variable. And then it's going to go ahead and get subsets of that data, of that movie's data. Now, the first two of these are probably the most complex, and it's the actors and the genres. And that's because if you look at the data set itself, they have a comma delimited string of all of the actors in a movie, or the top 4 actors, or column delimited string of genres. And I needed to split those. And so, it's done in the same way for both actors and genres. So what it's doing here is, starting on line 43, it is going to take the movies, it's going to get the actors, and it's going to split that string based off of a comma. That's how they're delimited. And it's going to put that to a list. But then it's going to put this into a data frame, and it's going to make the rank for movies the index for that data frame, and it's going to stack it on top of each other. So instead of ending up with a rank and multiple columns wide, it's a rank and a pivot. And then once I have that, I'm going to go ahead and reset the index and change the column names and return that actors back. So what this gives me is the rank of the movie and the actor. And so if movie ranked number 1 has 4 actors, I'm going to have 4 rows, 1 with each of the actors. And the same thing happens for genres. It's the exact same splitting on the comma, and then doing the stack and resetting the index and so on and so forth. Then you get into load revenue, ratings, director's years. Those are really straightforward things that you would normally see inside of Pandas, where I'm actually just selecting off of movies the rank and the revenue, or the rank and the rating, or the rank and the director. Like I said, pretty straightforward. Rank in all of these cases is going to be the key that we're going to use to join on when we do our analysis. So that's the cleanup phase. That's getting all the data loaded and ready to use. Once we have that, then we have some public methods that are going to be used. That's what we saw here on the application itself, that would let you get the actual data. So we start off with the rating methods. And so like here for get rating by actor, we're going to, of course, pass self in, but we're going to pass a limit in. And that's so that obviously there's a lot of actors potentially in this. We can limit it down to how many we want. If we want top 10, or if we want the top 20 or 30 or 40, whatever, that's what limit's going to do for us. What we're going to do is we're going to come in here and we're going to get the actors, and we're going to merge it with the ratings. That merge is going to happen based on the rank. And then we're going to take that subset, we're going to group it by the actor, return the rating, and we're going to get a mean on that rating, and then reset the index so that we have a data frame. At that point, what we'll have is we'll have every actor and their average rating. Then we're going to throw this into a bar chart in this particular case. We're going to throw it into a bar chart. We're going to have the bottom, or we're going to sort it first on rating so that we get the top ratings. Because we just want the highest ratings first. And then we are limiting it based on the limit that we pass in. We're going to say the x-axis is actor and the y-axis is the rating. And in our case, because this is an average rating, we're going to change the rating label to average rating. And then give it a title and return that. And so what this did is it allows us to, inside of our app itself, just create one movie's repository and then go and get all of the charts that we need. And again, most of them are pretty straightforward, pretty close to the same. The ones that are really different are let's see where we're doing it, is the revenue ones. So with the ratings, we're giving an average. With the revenue ones, we actually need to get a sum. And more to the point, I didn't want to account all of the revenue of a single movie to all of the actors, because it would make it look like the revenue was duplicated or triplicated. And so what I did is I actually went in and I grabbed the actors first, grouped by their rank, and I got a count of the number of actors and put that into this data frame really quick so that I had a rank and how many actors there were. I merged that with the revenue, and then I did a division so that I divided the revenue up evenly among all those actors. Once I had that relative revenue, that's when I then merged it with the actors in general, just like we did above, and did a sum. And so now we have the relative revenue per actor across all their films. And then again, return, in this case, a bar chart. So I'm going to not go through everything, but I am going to run this, and so that you can see what this looks like. Okay, so let's see if this will start. You might have to actually run it from the command line. Okay, so here it said it went ahead and started my Flask server, whatever it tells me what the environment is, and it gives me this this link, so I can command click on it, and that is going to open up my web browser with all of these charts. Now, one of the things that was a requirement of the project was to make this interactive. I do not have it interactive in the sense that you can go in and change the number of actors you want from 10 to 15 or whatever, like with a drop down or a slider. However, it is interactive because of the library I'm using, where I can do things like all of these look pretty close to 9, so maybe I can grab this and I can move this down, and so I can start to see the differentiation a little bit. This one's not the greatest because they're all so close together, but let's see if we can do it on this one. Or maybe not. But anyways, you can move them, you can slice it, you can choose a subset, things like that. Here on the scatter charts, this happens to be average rating by revenue. I actually found this one really sort of interesting because it seems like there's a big cluster here around the ratings being fairly high, but very low in terms of revenue. Whereas there's this one outlier way the heck out here that the revenue was really high and it got an average rating of 8.1. What that sort of indicates is that the amount of money you spend doesn't equate to your rating in IMDb. There's actually quite a few movies that are rated pretty highly that have almost no budget whatsoever. There's also average by year. So let's see if I can show you on this one. Oh, maybe not. There's a way. I must not be hitting it right. That you can get it to shrink the axis a little bit. So all of the things that we looked at, all of the things that we needed are in here. All the different slicing and dicing. And so that is it. And then it's interactive in terms of if you've done something and moved things around or what have you, like in this particular case where we subsetted and only selected 2, you can click reset accesses and it will take you back to where you were. And this is all through the Plotly library, so which is pretty nice. So anyways, that is my project, and I appreciate all the hard work and guidance you have given, and thanks for letting me participate in the class.